Imagine a world nearly 4 millennia ago, a time long before the first microscope ever revealed the invisible swarm of bacteria, and centuries before modern medicine began to grasp the complex mechanics of viral infection. On the sun-drenched, rugged island of Crete, the Minoan civilization was achieving something that even today's most advanced smart cities struggle to perfect: a truly self-cleaning, biosecure urban environment. While other ancient empires were frequently decimated by the sudden, violent outbreaks of disease, the inevitable filth born of their own success, the inhabitants of the palace of Knossos were walking on dry, sterile stone floors. They did not possess modern antibiotics, yet they had a profound, intuitive understanding of biological security. They did not have electric pumps or high-pressure sensors, yet they commanded the water to move with the force and precision of a mountain torrent. The Minoan water supply and drainage system is not merely an archaeological relic to be stared at in a museum. It is a masterclass in the laws of fluid dynamics and a monumental testament to the idea that architecture, when combined with physics, can be the most effective form of preventative medicine ever devised. Close-up of crystal-clear water erupting with extreme force from a 3,500-year-old terracotta pipe, instantly blasting away centuries of moss. This is the visual reality of a technology that refuses to fail. Macro-internal camera view sliding through a clay pipe, revealing a unique bottleneck taper that creates a high-speed water vortex. It is a world where a split-screen transition reveals the harsh truth. A modern flood zone filled with stagnant, diseased sludge versus the perfect, dry sanitation of the ancient Knossos palace. Aerial cinematic sweep of Crete's coastline at the golden hour shows the architectural grandeur of the Knossos palace. A sprawling labyrinth protected by more than just stone walls, it was protected by the clay beneath it. High-detail shots of Minoan craftsmen kneading red clay by the Mediterranean Sea remind us that this was a technology born of the earth. A master engineer sketching pipe designs on a clay tablet using a bronze stylus shows the intentionality of this design. It was a 3D X-ray vision of the future, looking through the palace floors to see miles of interlocking pipes running like a nervous system through the dark soil. The genius of Knossos is hidden in the geometry of the bottleneck. Each individual pipe was slightly conical, narrowing at one end to fit snugly and precisely into the wider opening of the next segment. This was a high-level engineering strategy to create forced pressure through pure geometry. By narrowing the channel through which the water passed at every joint, the Minoans were utilizing what we now call the Venturi Effect, thousands of years before it was formally defined. As water entered the tapered section, its velocity increased dramatically, creating a constant, high-speed jet that pulsed through the system. This rapid flow generated a physical scouring action against the interior walls of the clay pipe. In a typical flat or wide-bottomed pipe, the flow of water slows down, allowing heavy particles, organic waste, and silt to settle at the bottom. This stagnation is the birthroom of biofilms, those thick, slimy layers of bacterial colonies that serve as the foundation for pathogens like cholera to thrive. But in a Minoan pipe, the water moved too fast for any microscopic enemy to take root. The physics simulation shows blue particles accelerating as they pass through the neck of the pipe. Comparative shots between a modern flat pipe with debris settling versus a Minoan pipe where nothing can rest demonstrate why this ancient tech is superior. High-speed fluid simulations show water scouring the interior terracotta walls, leaving them pristine. Macro shots of the smooth fired clay surface show zero biofilm or bacterial slime growth. A Minoan engineer pouring dyed blue water into the system to test the flow velocity confirms the efficiency. Close-ups of the U-bend trap show an ancient version of the modern S-trap to prevent gases from rising. Side views of the pipe's incline show a precise 2% slope maintained across rugged terrain, utilizing the power of gravity without the need for a single pump. The choice of material was as brilliant as the design itself. Fired terracotta is humanity's oldest and most resilient technology. The Minoans understood that fired clay is naturally dense enough to provide a smooth, low-friction surface that resists bacterial adhesion. Unlike lead or iron, which can corrode and poison the water, terracotta is chemically inert. It preserves the water's natural alkaline balance. Infographics show that stagnation equals death, visualizing bacteria multiplying in still water while being shredded by the sheer force of Minoan high-velocity flows. Microscopic views reveal pathogens being destroyed by the mechanical energy of the water. Sedimentation tanks allowed sand and heavy grit to drop out of the water before it ever entered the high-speed pipe system, preventing erosion of the clay walls. A Minoan queen using a terracotta footbath shows how the water drained instantly without splashing, maintaining total hygiene. Close-ups of the salt-rich air of Crete reacting with the clay show how it acted as a natural mild antiseptic. Rainwater was harvested from the palace roof and funneled into the purification system, ensuring a constant supply of fresh, moving water. The manhole view shows stone covers being lifted for annual inspection, revealing a surprisingly clean interior even after years of use. This was an industrial solution built by hand, a way to provide biosecure infrastructure for pennies. This ancient wisdom carries a vital, urgent message for our contemporary world. When a modern flood hits a developing region, high-tech sewage systems are often the first to fail. Power grids go down, and electric pumps seize under the weight of mud. When the water stops moving, death begins. Stagnant floodwater becomes a toxic reservoir for cholera and typhoid. This is where the Minoan bottleneck design becomes a potential lifesaver. Modern disaster relief workers molding clay into the Minoan tapered shape in muddy refugee camps show the power of local materials. Installation scenes of laying terracotta pipes without electricity demonstrate a sustainable future. Physics demos show how the bottleneck design prevents silt clogging during heavy mud flows. Cost-benefit charts prove that ceramic pipes made from local materials outperform expensive plastic imports in resilience. Gravity-fed village sanitation systems, inspired by Knossos, offer an anti-cholera shield that saves lives. Drone shots of a sustainable, biosecure village using ancient Minoan principles prove that we don't need high-tech gadgets to solve basic human problems. Time-lapses of 3,500 years of earthquakes passing over buried Minoan pipes show their seismic flexibility. The interlocking male-female joints allow the system to flex without breaking, a design far superior to rigid modern piping. The philosophy of the Minoans was one of absolute harmony with gravity. They did not attempt to fight the weight of the water, they accelerated it. They did not hide their waste in dark, stagnant pits. They flushed it away with the mechanical power of the Earth's own incline. They recognized that to keep a city alive, its fluids must never stop moving. In the ruins of Knossos, we see a civilization that achieved a level of public health that the Western world would not see again for nearly 3,000 years. The labyrinth drainage tunnels, deep underground, show the scale of their ambition. Sustainability is not new. It is 4,000 years old. Slow-motion splashes of water hitting the entrance of the pipe system transition into particle tracking animations showing the spiral flow. Diagrams calculating the Reynolds number prove that the Minoans understood the difference between turbulent and laminar flow. High detail shots of the clay kiln firing at 900 degrees Celsius show the birth of the antibacterial shield. Modern engineers looking at these pipes through 3D scanners are still learning from their internal geometry. Scientific conclusions are simple: minimalist engineering with maximalist results. Scenes of Minoan festivals, where people drink from public fountains fed by the pipes, show a society obsessed with physical vitality. As the sun sets over the ruins of Knossos, the sound of water still rushing through the ancient stone serves as a reminder. The architecture of health is the only architecture that stands the test of time. The pipes of Knossos are a silent prophecy. They remind us that nature already provides the answers to our most pressing health crises, if only we are wise enough to listen to the patterns of the past. We have the computers to model the flow. We have the kilns to fire the clay. But do we have the courage to build with the same simple, effective foresight? The lesson is clear. To protect the life of the people, you must master the velocity of the water. Let the water move. Let the pipes breathe. And in that movement, we find the path to survival. Split screens between ancient ruins and futuristic eco-cities show a path forward. A hand-drawn sketch of a pipe transitioning into a 3D digital model symbolizes the bridge between eras. The Minoan blueprint is now a digital map for global NGOs. Slow-motion shots of a clay pipe being fired in a kiln mark the rebirth of sanitation. Atmospheric shots of the sunset over the labyrinth conclude our journey. Architecture is the ultimate medicine, and the clay of Crete still holds the cure for the stagnancy of the modern world. Fade to black with the sound of a single, pure drop of water hitting a stone floor, heartbeat of a civilization that refused to stay still.
Thank you for watching. This immersive experience was brought to you by the power of AI storytelling. We use artificial intelligence to reimagine the past and entertain the curious minds of the present. The quest continues.